Today we're designing a custom 3D printed transport case for these guitar remote controls. The goal is simple: keep them perfectly protected while making the box compact, strong and easy to print. In the previous video we designed these blue inserts that hold the devices securely. Today we'll design the full case around them, including a hinge and a magnetic closure. But there's one small challenge: designing a hinge that actually moves correctly after 3D printing can be trickier than it looks. And later in the video I'll show you the small detail that makes the difference between a hinge that works and one that is completely stuck. Let's jump into xDesign. To start, I create a new part from the menu. Then I insert the existing blue components from the recent components list. The first component is fixed by default, which is perfect for positioning. Since I need two of them, I simply use the universal copy and paste. Selecting the components on the left gives access to the manipulation arrows, so I can rotate and position them correctly. To fully constrain the inserts, I use standard mates. All xDesign components include default reference planes, so I simply Control-select two planes, and the contextual toolbar proposes the most relevant mate. Most of the time that's coincident, so it's first on the list. To improve visibility, I temporarily hide the top parts. Then I roughly position the inserts and finish with a distance mate of 2.5 mm between two vertices. We can now start designing the actual box. To define the outer shape of the bottom case, I start with a sketch. First, I create a construction line and place a midpoint to center the design. Then I create a center rectangle around the inserts. Because the rectangle is centered, I only need to control dimensions on one corner. When the sketch geometry turns black, it means it's fully defined. Next, I create another rectangle that will define the charging cable cavity. To constrain it properly, I simply drag one endpoint onto the other rectangle until they become coincident. Now the sketch is ready, I transform it into a solid extrusion. Next, I need to decide the height of the case. After a few quick tests, 22 mm looks like a good compromise, strong enough without making the case too bulky. Now we need to create cavities for the inserts. Instead of redrawing their shape manually, I want the geometry to stay linked to the original parts. So I simply convert the edges of the blue components into the sketch. This creates a parametric link, so if the inserts ever change, the box will update automatically. Before going further, here's something important for 3D printing. Later in the video you'll see why the 0.2 mm tolerance I'm adding here is critical for this design to work correctly. For now I create an offset of 0.2 mm around the insert geometry. I also account for the 5-degree draft already present on the inserts. Let's take a quick look in section view. As you can see, the gap and the draft angle look correct. I also add 0.2 mm clearance at the bottom of the cavity, so the inserts will never protrude above the surface of the case. Next, I create the charging cable cavity. Again, I leverage existing geometry to find the center of the part, and I create a center rectangle. I don't use the entire available space because I want to leave room for something that will keep the box closed later. For now, I just dimension the sketch and link it with the other cavities, so everything updates consistently. Once the sketch is ready, I use cut extrusion to create the cavity. xDesign conveniently keeps the previous depth value. Since this case will be stored in a bag, sharp edges could damage other objects, so I add rounded corners on all external edges. After testing a few values, 6 mm fillets look better than 4. But when working with hollow parts, it's always important to check how fillets affect the internal thickness. Let's check again with section view. The insert cavities look good, but the cable cavity is getting a little too close to the bottom. That could weaken the part. So I reduce the cavity depth from 20.2 mm to 18 mm. At the same time, I increase the width slightly to keep enough space for the cable. So now the bottom case is fully defined. Outer shape, insert cavities, cable storage. Now we can design the top part of the box. First, I make the upper inserts visible again so they can guide the design. Then I create a new geometrical set and rename it top case. After activating it, I can start designing the lid. Since we're using parametric CAD, we should reuse existing geometry whenever possible. So I project the bottom case outline into a sketch. That way I don't need to enter new dimensions. If the bottom changes, the top updates automatically. Next, I create the insert cavities using the same process. I project the insert boundaries, measure their depth, and add 0.2 millimeters clearance. And this is where the tolerance we added earlier becomes important. Without that small gap, the inserts would simply get stuck after printing, and you just couldn't close the case. Now comes the interesting part, the hinge. Remember earlier when I said designing a hinge for 3D printing can be tricky? The problem is clearance. If the geometry is wrong by just a few tenths of a millimeter, the hinge simply won't move after printing. So let's design it carefully. I start by sketching the hinge profile on the side plane using lines, circles, and arcs. Then I create an extrusion using the mid-plane option, so the geometry grows symmetrically. I modify the sketch so the hinge can accept 3mm bolts, and I reinforce the geometry slightly. To make it easier to distinguish the parts, I also change the color of the top component. To allow the hinge to move freely, I add a small clearance gap. Using advanced extrusion settings, I start the feature 0.1 mm away from one face and end it 0.1 mm before the other. That small tolerance is essential for 3D printed assemblies. For the screw holes, I reduce the diameter to 2.9 mm, so the screws can create their own threads in the plastic. Then I need to create out a hinge segment. Look how I can use the sketch I created on existing solid geometry to start further, where I needed to. This will avoid creating a plane that would be used only once. Very convenient. And now I just have to mirror this segment to the other side to finish hinge design. Finally, I add fillets so the hinge can rotate. At first the hinge would block the movement. But here is the trick. The fillets must share the same center as the hinge axis. Once that's done, the lid opens smoothly and the hinge works perfectly. So now we have the bottom case, the top case, a fully functional hinge. All that's left is making sure the case stays closed. Remember the empty space we left earlier near the cable cavity? This is where we add a magnet. Since I don't want to extend the external shape of the box, I use a rectangular magnet. I create a centered rectangle and cut a small recess. To align the pockets perfectly between the lid and the base, I simply project the sketch from one part to the other. If I change the magnet size later, both pockets update automatically. This keeps both features linked, as we can check in the section view. Now it's time to make things real. Using the Print 3D tool, I check the orientation and verify the parts fit inside my printer. That would be embarrassing if they didn't. Then I export the parts as STL files. Good news, both pieces fit on the build plate, so I can print them in a single job. And now, it's printing time. Once printing is finished, assembly is quick. First I glue the magnets, then I glue the blue inserts. You'll notice I use less glue on the inserts than on the magnets. I forgot to record the screw installation, but it's straightforward. After tightening the bolts, I test the hinge. It's strong and smooth, exactly what we want. And here's the final result. The inserts hold everything securely. The hinge opens smoothly, and the magnets keep the case closed. Exactly what we designed. If you want to try this project yourself, head over to solidworks.com/makers and start designing today for a very affordable price. You'll also find plenty of tutorials and examples to help you get started. Thanks for watching, and see you in the next episode.